computer. I am plugged in. My power almost went out last time, so I'm double checking the power cord this time that we actually have this. Can everybody hear me all right? Everything good?
This should buckle up before nationally televised.
I'll take that one as a yes. All right, cool. So in that case, again, welcome to Thursday. Today we're going to be going over Java tooling and exceptions. I didn't really know a good gift for this one, so I found Simpsons. I was a huge Simpsons fan when I was a kid, like huge Simpsons fan. I think my dad was addicted to it or something like that, so I had to throw that in there. But surprisingly, what, it's like season 38 or something like that? I don't even know anymore. Good animation thing. All right, let's move into, there we go.
They're on season 32. Sorry.
32. Thank you. Actually, I really did want to know that. That's still ridiculous. I was actually thinking like 30s. That's crazy. And it's still the same voices too. I don't know. Mind blown. Anyway, announcements. Get ready for assignment 3. As we kind of talked about before class started tonight, we do not have an exercise or a studio in our breakout sessions, but it is absolutely crucial that we go to those breakout sessions still, ask those questions, and review what we've learned. We have learned a lot since our first lecture in Java. You have learned how to do variables, interfaces, abstract classes in general, and now into Spring, which is completely something, a different kind of architecture. Your mind should be blown because mine is just explaining all of this. Ask those questions tonight about exactly what maybe a knowledge gap that you have in any of the things that we've learned about Java or even JavaScript to your TAs. Really, really use this night to catch yourself up on anything that you might need just a little bit more explanation for. All right, so let's dive into today. What we're actually going to start with is not Java tooling or exceptions or anything like that. We're going to actually talk about day in the life, something that I haven't really talked about yet in any of these lectures. What it is to be a developer after we've crossed the finish line for LC 101 into liftoff and we start preparing ourselves for corporate. What is exactly that kind of life? You probably already heard some things from your friends or other TAs or anybody else you talk to that's a developer. So what is it like a life in the developer? Well, there's 4 major things that people typically hear about. The first one is formal attire is very optional. In my particular environment where I work, if you ever dress formally, someone's going to ask if you're okay. Mainly because we don't do suits, and business casual kind of is on the fancy side as well. I've seen a lot of people in khaki shorts and t-shirts. It's a great life in the developer. They try to make you as comfortable as possible. That being said, it's a very laid-back environment, focused on sharing ideas. Collaboration is a huge part of the developer community, as you might have already seen on Stack Overflow or just working with your fellow coders. There's also a continuous push to learn, as in new technologies are always coming through the door. Though the languages might not change, architectures or how we use something might. So it's always a pressure on us in our corporate atmosphere or organization to continue learning new things coming into the door. That's a big thing about development, is that we always have to stay up to date with our technologies, so we make sure our applications are up to date. And then finally, I know this is a very lush, it might seem like a very lush environment to be a developer, but we do have one underlying expectation from all of our managers and the business in general. The developer has an overall expectation to contribute. So what do I mean exactly by contribute? Well, let's put it into the perspective where we are today. So we are in the class life right now. And when we're faced with a task, an application, or an assignment, we are managing that personally. We're managing our own personal applications. We're building our personal application, completing our assignment. We're building that from the ground up. We are doing this single-handedly, maybe with some help externally, but it is mainly our application. We're writing it on our own timeline. So we might write it very quickly because we get some of the concepts, or we might write it a little bit more slowly. We're on our own pace because we're learning here. That being said, going into the team dynamic, when we go into corporate, you do not work on applications by yourself. That is not the development lifestyle. Developers rarely work alone. We work in a team atmosphere. We work together to create applications and maintain them. So you are not going to be typically working on a project by yourself and you deliver that, kind of like what you do in the class atmosphere. Instead, you work as a team, placing things together. So when you're in a team environment, it is absolutely crucial to always contribute, especially timely. Because if someone on your team does not enter that piece of the puzzle that you need to complete your application, The other people on your team that are dependent on that puzzle piece will become extremely confused and nearly agitated because now they're held up waiting for you to complete your things. This is always the crucial part of the development lifestyle, to always keep up to date with your team and keeping just essentially an understanding among your team of where you are in your application. A lot of these practices that I'm mentioning will be more talked about in liftoff when we get there. I'm just going through just an overview to get you introduced into it. So if that person does not deliver their piece, like I said, the application cannot move forward. We are basically halted. The business is asking for what's going on, and essentially we can't really tell them when our application is going to get out the door because we're waiting for someone. So that's why it's always, again, crucial that everyone is on the same timeline. Teams only work if we're on the same timeline. Otherwise, everything falls apart, and you might as well work individually, which, by the way, people working individually, especially programmers, productivity and communication go out the window. Hence, we work on teams. So why am I telling you all of this? It's because what we do here today in Liftoff, LC 101, and the expectations that they have are mimicked off of what the expectations are in work life. When we're putting these applications together, whether it be in our work-life balance or our personal life here in class, it is absolutely crucial that we keep timely contributions, turning in assignments on time, because this is our main expectation as a developer. So why am I saying this? Why am I telling you this now? Is because we just completed assignment 2. We have assignment 3 and assignment 4. And I know going through these cohorts and seeing everyone that it is getting a little bit of a struggle. It is a lot of work to get where you are all at, and you're all doing fantastic. So I'm telling you this now because don't put the wayside of assignment 3 on, or don't put assignment 3 and assignment 4 on the wayside, because 1, that is just going to hurt you in the long run. And 2, we're here to become developers, understand how to do development, as well as how to contribute when we do go into this industry. Hence, we want to keep it in a timely manner. So always make sure that you're meeting these expectations. But you might be asking yourself now, or just like shaking your head at me for saying this, asking yourself, what if I can't meet these expectations? What if I am severely struggling for whatever reason to come across or to overcome knowledge gaps inside of my applications? Well, that is a typical thing that we meet as a developer. You feel knowledge gaps, I feel knowledge gaps, everybody in the development community will feel knowledge gaps. Essentially, we will always have questions. When you run into something and the puzzle pieces aren't fitting together, you know something's wrong with your application. I know something's wrong with my application. And the one thing we can all come to an understanding about is that we have a question. No matter what's broken or anything, you know deep down you have a question about why it's broken, how it broke, things along those lines. But in the end, you have a question. This can be, again, in the class life or in the work life. No matter where you're at, you're going to come across questions. And in the development community, as I said, it's always going to be questions. So it's not about having the question necessarily, but it's about how you phrase or ask your question out into the community or another colleague or a boss person or a TA. It's about how you phrase your questions. And how you phrase your question might either add weeks onto your timeline because you can't overcome that knowledge gap, or will just take a few minutes. So it's really about how you construct your question that really helps you out in the end. Some example of questions that would add on time to this timeline is, my code is broke. Something is wrong with my app. I can't figure out what's wrong. These general statements or even general questions don't work. If I went to one of my colleagues at work and asked any of this, they would give me a blank stare and say, do you want to get coffee or something? Like, what do you need here? They would have no idea how to help me because I didn't phrase a question to them. I didn't give them a good statement of my problem. I just told them that I'm at the start of investigating my own problem. This is extremely important to know as a developer. You are not only a creator of beautiful applications, but you are also now an investigator. You wear 2 hats. You have a magnifying glass of that investigator part when your creation goes astray. So what do I mean by this? Well, since you're a creator and an investigator, before you ask a question, as a good investigator, you need to question yourself. So if you're met with an error, you need to make sure that you're questioning yourself before you question others. So let's talk about just a small smidge bit of a problem. If I come into this application and I run it, and it's just a brand new day, I'm waking up on a Monday morning, I put it away like the other day, and I come in here and I see crud. I just press start and nothing works. If I go again to my colleague and say, nothing's working, I don't know what to do, I know I just lied, because at this point, we know that we at least did something to start understanding the problem. And the first question you would ask is, can I compile my application? And what I just did there was try to compile it. I can try to compile it and nothing worked. I got this weird bug down here. So ask yourself, can you compile your application? It's a yes or no question. In this one, I said, no, I cannot compile this application. I have no idea what's going on. So I asked myself again, okay, well, I couldn't compile it, but is there an error in the terminal? Well, I can look at that too. I said that there's some kind of weird identifier thing expected here. Well, I just told you what it said. It says I have an identifier unexpected or something like that. So at this point, I know I can't compile. I'm getting an error, and the error says identifier expected. Those are the keywords I saw in that error. Let's see what else I can get. When was the last time I compiled correctly? Well, like I said, it was just like the other day. Like I just had it running, I swear. Just had it. And then I asked another question, a very important question. What have I changed since then? Have I done a different for loop somewhere? Have I done an if statement somewhere that now it's not working? Do I need to take a few steps back and reapproach that problem? Maybe that's what happened. But what if you say, I don't think so, but my cat might have stepped on the keyboard? Well, in that case, this is kind of a question. I would understand this. Like, okay, we have a question here. I don't know what's really going on. Everything in my code seems to be working. I looked through everything and I couldn't see anything exactly. So what if we're on to that kind of scenario? Well, what we can do is that we would ask the question out into Slack, out to your colleague, out to an individual that you trust and feel like they have knowledge, saying, hey, I'm getting an identifier expected error in my code. Sorry, my animations are off. Do you know the typical reason for this error? This question is not asking necessarily, how do I fix it? How do I necessarily find the error or anything like this? It is literally just gaining more intel, more intelligence on what this even means, because I don't know what this identifier expected exactly means. And someone will typically just return to you some general knowledge saying, oh, usually it's when you just have a random character somewhere out of place in your code. So this, again, as the investigator, as the coder investigator, you are just given another hint to solving your case. So knowing that, we come over here and saying, okay, now I'm looking for just a general error somewhere in my code. I see an IntelliJ, I have it under red, I have it under main. Go into cat, I see it's underlined red, and I see that my cat sat on my cat class. So I take out those random characters and I try to run again. And now everything should be running. What we just did was not ask a question of how to fix our code, but ask a question of hints towards fixing our code ourselves. So that's specifically what we're trying to do here. Oh my gosh, I did not do that one correct. We are asking questions to help our investigation, not to investigate for us. This in corporate, in liftoff, and as for finishing up LC 101, our questions should be more about how to discover the problem ourselves rather than trying to get more of an explanation of where it could be. Of course, we'll always come across those problems where we just need that one-on-one help, and that's not a problem either. Neither are general questions. But when we know it's a problem somewhere in our code, our first instincts as developers should be try to investigate it ourselves and solve it before we try to reach for outside help. This is the day in the life of the coder. So, any questions on that before we move a little bit deeper into some of this?
Nope.
All right.
Well, what if you did all of that, you know, investigated, tried all that before you actually went out to ask? Um, so is that something different if you given all the information as far as letting them know what you've tried, what the exact problem is?
So when you have reached the end of your investigation, you do need to reach for outside help. Again, it's not a problem at all. It's then we have to formulate that question with all the information that we've gained to the person we're asking. So to answer your question, include the error that you found. Was it an identifier issue? Was it an exception? Include that in your question, saying, I'm getting this. I did this, and I'm still having problems. If it's within reason too, explain also what you've done in the past. But in the end, you want to pass on as much information to the person you're asking for help of the problem that you're having. You don't want to ask a general question. That's the end of this. You don't want to ask a general question. You want to ask with as much detail and as specific as possible.
Okay, thank you.
Absolutely. Anybody else have any questions? All right. Then we're going to do one more investigation. So what if I'm in here and I say, can I compile my application? And I'm getting this error now or something like that, such as I'm getting an error here once I reran my application. Well, I was able to compile, but now I'm getting some kind of problem within my code as it's running. So the answer to this would be, yeah, I absolutely could run it. And then it asked me, okay, is there an error when I compile? I'm like, yeah, there's an error down here. Well, when we get an error while we're running our application, this is not like when we pressed the compile button and it couldn't compile at all. This is when we actually ran our application and it does compile. In our terminal, we'll typically get something that you see as an exception. This typically points to an exception. Something unexpected happened in our code. So you have probably seen this now since we have been working with Java quite a bit, and also you might have seen it in JavaScript too. There are some exceptions there. But let's talk about a little bit what exceptions are. It is something something unexpected that has happened in our code. So let's take a look at a close example. I'm gonna drink water because I'm getting tongue twisted. Oh, there we go. All right. We have a string here and we set it to null. My question to you is, who can tell me what happens here?
Null cannot equal null.
Say that again.
Null cannot equal null.
So possibly. Our string can equal null. That's completely fine. But what would happen? Who can tell me what could happen on the second line?
Can't run the toString method on null.
Yes, exactly. Okay, and Daria, if you were saying that, I apologize. But yes, you're absolutely right. You cannot. It will absolutely explode at this point. This is not allowed. We cannot do a toString on a null. What this is, what just happened, is an exception. And this specific exception was a null pointer exception. So if you see this in your code, this is what's happening, is that something is set to a null somewhere and you're running a method on it. But remember, you can't run method on nothing, on null, so it blows up. How about this one? My string, not a number. But then we need to parse it. Is not a number a number?
It's a string.
The string,
No.
but not a number. Even if a string was 7, we could technically parse it, but not a number is full of characters, full of alphabetical characters. So in this case, we blow up also, which is not a good thing. We don't want that. And what this is called is an exception. It's called a number format exception. As we can see, there are different types of exceptions out there that pinpoint a general direction in our investigation to answer our questions. Exceptions are named something specific to help us out as developers understand what's going wrong. One more fun one. What's going to happen here?
What the fuck is that?
We're gonna blow up, right? We're gonna totally
It's
blow
outside
up.
the ring.
It is way outside that array. This is called an array index out of bounds exception. This one is telling us that we are trying to get something out of a set array way outside of its bounds. So this will definitely make things blow up. So now that we know that exceptions exist, can anyone tell me any other exceptions that they've seen? Anybody?
I think I've seen type exceptions where I put in like well, I'll say int string, and then you'll end up putting a number there. You get them messed up and they won't let it go through.
Okay, yeah, type exception, cool. Anybody else?
Like a runtime exception.
Runtime exceptions, that's a fun one. Yeah, that is a good one. Cool, okay. No, I like this. So everyone's seen exceptions. Everyone's getting, well, I wouldn't say getting comfortable with exceptions. No one gets comfortable with exceptions. Honestly, they cause like backaches and like stress, and yeah, they're terrible. Terrible people. All right, but we're gonna talk about how to kind of just, coexist with them. So we're gonna come into here and we're going to just see that those kinds of exceptions in action. This is the one that we had up here. Let me take that out. This one is, we create an array of 1, 2, 3, and I'm trying to ask for this array of 4. Like I said, we run the application, it does compile, but it then throws the exception. Remember, exceptions typically happen after compilation, after we're running in the application. So this is our exception, that array out of bounds exception. Index 4 is out of bounds of length of 3. I'm showing you this because as we're investigating these errors into the future, look for these telltale signs. Java is trying to help you as much as it possibly can to pinpoint where to at least begin correcting code. I forgot. Anybody else want to see another one? I'll probably show you this null one too. So we say the null string to uppercase, even anything. Like, it doesn't have to be to string, it can be to uppercase. Any of the methods on there, you're going to get Java very angry at you. And here we go. We see that null pointer exception, and it's saying or it even tells you the package name to find the error in, and even the line number. Not only that, it gives you a hyperlink. So if you click on it, it takes you directly to where that error is at. I'm sure you've all seen this by now, but just want to show it to anybody who needs a quick reminder. Java wants you to correct it because Java likes to run. Java doesn't like to just have a bunch of exceptions. All right. Let's move on to one more exception that we might see with inheritance now coming down the line with all of us. We have a new pet here. We've done this in, not the last example, but about 2 lectures ago. We've seen pet and we've seen dog. We create a new dog here and we save it into pet, where pet is the parent of the dog class. This line is trying to convert my dog or my pet into a cat. If you try to convert a dog in real life to cat, what would happen at that cat dog park? I don't know where you try to do that at exactly, but where would you try to convert, or what would happen if you try to convert a dog into a cat? Would it be happy? No, you probably get World War II there. You do not want to try to convert a dog into a cat. It would definitely blow up. This here specifically is called a class cast exception. So this is a common one that we can come across while doing inheritance. So what if we were to expect the unexpected? What if we were instead to continuously argue with this class cast exception? We actually welcome it, or we could try to predict it. And then once we predict it, we're able to, overcome it, or at least deal with it. Remember, exceptions are part of everyday life, but we have to kind of deal with them in our code. I'm going to type that example out here real quick. My pets, just make sure I'm not a liar, and make sure I have all my stuff there. Was it Stark? Then 7. And then we're trying to convert that cat. My cats equals. How do I cast something? What do I put in these parentheses? Anybody?
Object name.
Pet.
Or uppercase my pet.
So I'm going to try to convert dog to a cat. So I would actually put cat here. That's how we cast things. We put it inside those parentheses. And we say my pet, because that's what we want to cast. So we come down here, comment this out, because I want to get an exception all to itself. And there we go. We have that famous class cast exception. I really do not like how I made this my prime example, because that is a tongue twister and my tongue is not doing too well today. Okay, class cast exception. But like we said, we want to try to welcome these exceptions into our life. So let's take a close look at an example. We have our please pass me a dog, and we're going to have this method in here called new cat, and it's going to just pass in a cat. So we're going to create this method in here, and we're going to have this my dog object, exactly like we did in the last example, except here I'm just putting it into a method. So if I ran this right now in our application, we would absolutely get an output of a nuclear blast. We would definitely get that exception back. But like we said, we don't want this anymore. We know this might happen in our code. We know that there is human error out there. So we want to try to circumvent that or just handle it whenever it comes across. So we are going to input something a little new that we might not have seen in past Java exercises and examples. And to start protecting us against these exceptions, we use the keyword try. What this means is that I want to try a line or multiple lines of code and see if I get an error. If I don't get an error, that's all good. But if I get an exception, like I know I will in this example, we need to put the catch there. We need to put this catch keyword here because it's going to catch any exception that happens inside of those try curly brackets. Now, when our cast exception gets thrown, it will get caught inside of this catch. It will get caught inside of the catch. And so instead of breaking our application, it actually gets essentially diverged into this other bracket area, and where we can just output something instead of actually breaking our entire application. This is a way of saying we're basically predicting that this thing to break, and if it does break, do this, aka put some code inside of your catch block. So now when we put the system out, instead of getting output of a nuclear blast, we get, that was not a dog. Exactly what we print out to the screen. So this is a lot nicer than breaking our application all the time. So let's take a quick look at it and see exactly what's going on. So like we said, this was our example here. And what I'm going to do is put try around it. And then what was the second part that's attached to tries? It's always, always, always attached to tries.
Catch.
Catch, very good. And what was that type of exception that we would be catching here?
Class catch.
Class catch.
Class, thank you, I just didn't want to say the word. That one, class cast exception. And then I always just by default put EX here for exception. So you'll see that in all of my examples. That's usually just what I put. And then I do system.out.println. That was not a dog. All right, moment of truth. Let's see what happens. There we go. Instead of completely breaking and stopping our entire application, it says, oh, that was not a dog. This is a way that we can use try catches to, instead of breaking our application and completely destroying and having a terrible Monday, we can include safety nets. That's what a try catch is a safety net. And if it does get caught in that safety net, then do something. That's what we do with this here. Any questions about this specifically? Anything at all? Anything about tries? Tries and try catches are going to be very important, especially moving forward.
How would you know which exception to catch?
That's a very good question. You could know from the examples that we've seen, or because you see it breaking in your code. But sometimes that is just a pain in the butt to do. So I'll cover this now just to help us out, but it will be covered again a little bit in lecture. But typically, instead of putting the specific exceptions here, what we can do is put a very general exception. Like you all know at this point, object is the root of everything. Everything is an object. We can have parents to classes. Same with exceptions. Class cast exception is very specific, but it also has a parent class, a very general class called exception. So when we don't exactly know what exception we're going to catch, use the word exception here. Moreover, you can also, oh, I'm sorry, Jay, does that kind of answer your question?
Yeah, I think so.
Okay. Yes, if you don't know what kind of exception you're going to catch in particular, which most of the time you don't, because a lot of things can happen, you can just use the general word exception. But what if you know what the exception is going to be, or at least you know one of them? Well, you can also chain catch blocks as well. I don't want to blow anybody's mind, but I do want to show you this just to show you that it is possible. So if you know it's going to be a class cast exception, you can put that here and deal with it as such. If you know it's going to be anything else, you can deal with that like anything else. So this is the way you can chain catches and deal with these errors appropriately. Lisa, I see you typing. You want, what's up? What is up?
So should every code that we write have an exception block in it?
Only if you see it as dangerous code. That's a very good question. Try catches are very good at what they do, but we know that everything in our application is not dangerous. Try catches should be around things that we see that could go a little awry. This could be casting. It could be parsing. When you open or close a file, things like that. When you're doing things like that, that's typically when a try catch should go in place. As of right now, use try catches when necessary. Don't overuse them. Why should you not overuse them? Because if you try catch everything and you just tell your job application everything's okay, and it uses that safety net, and there's actually a problem somewhere in your code that shouldn't have been handled or shouldn't have been safety netted, then it's going to be much more difficult to find that error. Try catches are very, very powerful for protecting us, but if they protect us from the truth, aka our application is actually broken somewhere, that could really hurt us in the long run. So with power comes great responsibility. So to answer your question, Lisa, I would say be very stingy on using the try catches, but when you know you're going to be getting into something dangerous, again, like opening a file, those are typically the most dangerous ones, definitely want to use try catches.
Now, what about the order of your catches? If you had the exception first, would it still go to the second catch?
That's a great question. Let's try that. That's what I thought. Okay. Yeah. The answer is yes. It will check this one and then it will check this one. So very sequential. Very cool.
Print both?
No, it would only do one. So technically, as you saw, I got an error doing that. What this error is telling me is that, no, you shouldn't do this. You should have your exception, the most general one, last.
Okay.
So you should definitely do it by specificity. That's a word. But no, very good question. I've never looked into that one. But definitely keep your exception at the very bottom. Awesome, awesome question. Anybody else? Alrighty, then let's hop back into this. So we just went through our try catches. We just got acquainted. So let's take a closer look as a quick example here. We have that please pass me a dog method, just like last time. It takes in a pet though, and we have that try catch there. And we're also gonna call this please pass me a dog method. But we're gonna pass in that cat object once again, because we just wanna just cause chaos for whatever reason. Now, some of our methods are not going to want to deal with those exceptions. It won't have the power to, it will be so small that we shouldn't handle any exceptions in there, etc. Or you just don't want to. You have a general method that you want everything to handle in. Bottom line, I don't want this please pass me a dog method to do anything with the exception. I don't want it to print it out to the screen. I don't want it to even read it. What I want to do is just throw it back in whoever's called me's face. And how we do that is using that exact keyword, throw. We want to throw this exception or throw an exception back into whoever called me. In this case, it would be, please pass me a dog, whoever is on the right-hand side. And we say throw new. We're going to create a new instance of an exception. We're going to throw back an exception. That's the power of the throw keyword, is that it's saying, well, I saw that I've broken somewhere, but I don't want to deal with it here. I want to throw it back and let them deal with it because I just don't have that time. One more thing we have to do when we throw this, and this is extremely important. We need to make sure we put throws exception inside of the method at the very top. Inside of the method declaration, sorry. Inside of the method declaration at the very top, right up there. It needs to say throws exception or throws class cast exception, whatever you want to throw. Once this, again, gets thrown back, it's going to go right back directly to whoever called that particular method. And so in this case, now that we're throwing in a method back in someone's face that doesn't have a try catch around it, what happens if an exception is not handled? What have we seen today? What happens if there's no safety net?
Blows up.
It blows up. Very good, Danny. Absolutely. So because there's no try catch around this, please pass me a dog, it's going to blow up. So to get around that, of course, we just place try catches around it. And then what would my catch block be? What would I be catching here? Or typically, what do I just want to catch?
Class.
We always want to catch one certain type of thing, and we've been talking about it today. It starts with an E.
Exception.
Very good. We always want to catch exceptions. That's the only thing catch blocks will ever catch is exceptions. So we passed in here, as we just talked about, that Jay brought up, the general version of exception. We pass back a general exception, and we're catching it here. Now, what if I wanted to display whatever this exception said? Well, we all know that classes have those methods inside of them that we can call to get information from. So in this case, we can just print out the message we got back from our exception. So now that we have this try catch block and we're printing out our message back, our output's no longer a nuclear blast zone. Instead, we're going to say, it's not a dog. So any questions about this before we see it in practice?
Now, did that come from the throw new on the left?
Absolutely, yep. What happened was that it immediately throws out of this method and goes directly into there. So we caught that exception that was thrown from the please pass me a dog method, and then we print out its message here, and that gives us our output.
Oh, okay. I think I get it.
Any questions on that, Sandy?
No, I think I got it. That's quite a moment, but it looks like it makes sense. Okay, thank you.
Yeah, no problem. Okay, so let's go ahead. I know this, it looks pleasant. So let's just go ahead and do it in practice just to make sure we truly get it. We're going to create that method here. And I'm going to create it static just so I can call it from this method. Static, what do we pass back? I don't think we pass back anything. Void, please pass me a dog. And taking a pet. And we said we wanted to do this. So what I did here is I created my method, please pass me a dog. I am passing in pet as a parameter. And I copied and pasted that try catch that we created above. This is going to come in here, and instead of creating my own pet, what I want to do is I want to convert the parameter pet into a cat. So, and then I'm going to switch this. I'm sorry, I want to switch dog. In my example, I did the other thing. My dog, I want to convert this dog. I asked for a dog. I said, please pass me a dog. And I want to try to convert pet into a dog. Any questions about that static method? All right, so we come up here. I'm going to take this out and I'm going to say, please pass me a dog. And I'm going to say new cat, LOL, no. We just pass in a name. I forgot where our constructors were. So we're going to run this and it should give us back what output. If we pass in a cat down here, what should be our output for this example that we're doing now? Will it go through and give 2 thumbs up, or will we get back something else?
Should we get that was not a dog?
Exactly, very good. We will get back that was not a dog because we're going to pass in a cat here and it's going to break. Let's go ahead and run that and double check. Oh, it is building, okay. There you go. And we get back, that was not a dog. So very good. Now, continued in our example, we said that when this happens, we want to throw a new exception. Can someone talk me through how to build this now inside of my catch? What do I need to start with?
Throw.
Throw, very good. And then what do we do?
New.
All right, what are we throwing?
Exception.
Exception, which is a general exception from all the other exceptions. And I'm gonna just put in there, this was not a dog. Now, once we did this, we see that we got an error beneath it. It's gonna say, because it's not handled. And we need to add an exception to the method signature. I click on that and it gives me throws exception up here. This is how we tell the other methods all over our classes, all over our application, that this method in particular will throw an exception if you really anger it. This is an absolute must in Java. And we know that because we just got that error and there's no way we could compile. So any questions on what we just did down here? All right, moving up. Okay, so it's gonna say, please pass me a dog down here, and we're gonna run this. First things first. What's happening here is that I did something previously, but what's happening here, why we're getting this error is because now this, please pass me a dog method is throwing an error, and Java knows that this is not gonna be handled by anything, so it might need a try catch. So it's saying, please put a try catch around this thing because it is dangerous. It can definitely make you have a bad day. So because we have to put a try catch around it, we have to catch something in our catch block. What do we typically catch if we just want to stay general?
Exception.
Exception, very good. And then we're going to system.out.println, and we're going to print that message. How do I get the message out of my exception? What do I type?
Exception dot to message.
Exception EX, because that's my name, dot get message. Very good. So here we go. We're getting our message now. Let's go ahead and run this and see what happens. Now it comes back with, this is not a dog. This is how we can control our errors and make us have a better day safely. But again, we're not abusing our power here. We use try catches when we absolutely needed to. Any questions about any of the example we just did or any of the previous material?
Okay, one. It seems to me like the second method we did required more code, but came up with the same response. Am I not understanding?
I think we have it all. You might see an extra line here. Sorry, I knew this was gonna throw, it threw me off. I put an enter here on throws exception. That was it. It looks like it's more code, but I only have so much space for the slides. So that's why it looks like that. But double checking, we'll do the try catch, try please, and then the catch system out. Try, please catch, system out. Then please pass me a dog with a pet and throws exception. Please throw me a dog, throws exception. Then a try, dog, catch, throw. Try, dog, catch, throw. So it looks like all of our codes here. Do you see anything else that might be missing?
Well, I guess I'm just trying to understand. It's both the throw catch and before you were using throw catch were coming up with the same response. So I don't see the benefit of using the throw catch.
So essentially, because we were using previously a system out down here, right? Instead of a throw, we got the same output. Is that what you were saying?
Yes.
Absolutely. So this is when we just want to system print. Down here, we originally put that system.out.println here to say there's something wrong. One thing to note that I just use system print lines here for an example. When something goes wrong in your application, that is not obviously, that is not a good thing. And it needs to report up its structure of how you called your methods to tell your main application something went wrong. Putting a system out.println here just basically masks that there's a problem. It doesn't help anybody other than yourself, maybe for some investigation. So we don't typically put system out print lines down here in a method that's being called by another method. We want to tell our method that called us, or the method that called it, that called that method, that something went wrong. We want to tell the chain of methods that are calling each other something went wrong. So what I'm saying here is that you don't want to use system out.print lines in your exceptions. You want to typically throw your exceptions as far up the chain as possible to tell somebody of importance in your application that something went wrong. I know it sounds really weird, but in the end, what I'm trying to say is that system out.println does not help you. Throw new exception does help you, because throw new exception will tell your parent that something went wrong. Tell the person who called you that something went wrong. System out.println does not. It just says, oh, nothing happened here, and walks away into the distance. So in the end, system out.println is not necessarily your friend in an exception. You want to use throw to let other people know something went wrong. I know I can't really show you this because this example is not going to get into those intricacies here, but you will see this, and so do remember that.
Thanks.
Awesome. Absolutely. Okay.
So should you always use throw when you're using catch?
Not all the time. And I wish I built a slide for this. As you can see, this is our main method. Our main method is our starting point, right? It is a heavy hitter method. We know this method is extremely important. Compare main to please pass me a dog method. If you were choosing a team for a dodgeball tournament or a method for a dodgeball tournament, would you choose main, the heavy hitter, or would you choose please pass me a dog method? Which one would you choose?
Main?
Exactly, main, because that main can probably throw a dodgeball. So what I'm trying to say is that methods have weights to them. What method does a lot of important things, and what methods just do kind of small little, just small things like adds 2 + 2, smaller things that you wouldn't really care about. Main is a heavy hitter application. Sorry, a heavy hitter method. So why am I telling you all this? Because in smaller, weaker methods, throw is typically used. You want to report up to somebody who's more stronger, like main, so they can do something about it.
Okay.
Yeah, hopefully that analogy helps out a little bit.
Thank you.
Yeah, absolutely. I wish I got a better explanation for that one, but that's what I got. But if that didn't get across to anybody, I can try to do a more intricate example too. So any other questions surrounding that? Because it can be confusing when to use throw and when to actually do something. To end on that, I use throw down here because it's a weaker method compared to main up here. So up here is where I would want to do something. I called to please pass me a dog method, and it told me there's a problem here. So up here, I'd be like, okay, I want to print out, I forgot what it is. I forgot how you print out errors. You want to print out an error here. RINTL. You would want to print out an error here to the user saying, hey, there was a problem. I was just trying to add your dog to my database or something like that. So to end that analogy, this is essentially where you'd want to put those error messages. You would want to put it down here, because what if you have an array of dogs? That would be the best example. So what if you had an array of dogs and you need to pass one in into the please pass me a dog method, and one of them is a cat? Well, you don't want your please pass me a dog method breaking every single time. That probably would have been the best example to do here. Yeah, I don't want to confuse anybody, but I also don't want to like over teach that. So I will probably be bringing an example here next class about some try catches, just to save us a little bit of time and also headache. Yeah, sorry. What else? What other questions about this try catch? And if an example does need to be done, just let me know and I'm happy to do it. I really just don't want to beat a dead horse, basically. All right. Then the final thing that we have to talk about tonight that we've seen in our reading is not, we talked about Gradle last lecture, we just talked about exceptions, and now today has been about how to investigate our problems. We know about exceptions now, we know how to gather intel on finding our problem. One more thing that we can use to help us with our investigations to find the culprit who's causing a terrible Saturday when we're just trying to finish an assignment is called debugging. I'm sure you've heard of it. And if you're anything like me, I thought it was the weirdest word when I first heard it. It's like, what is debugging? Not a fan of bugs. What's going on? And as we know in code, if something's broken, then we call it a bug. And debugging is exactly how it sounds. We're getting rid of that bug. And IntelliJ has a lot of tools in it that can help us find that issue. So say I have two try catches here for whatever reason. And in one, I'm passing a dog, and in one, I'm passing a cat. I run this, and I'm going to get back, that was not a dog, but, oh, what am I doing? Oh, I didn't have the correct constructor in there. There we go. That error was happening because I didn't provide something as in our side of our constructor to create a dog. It needs also an integer for its age. We rerun this. And what we're going to do is get back one that actually passed in the dog properly, and then we're going to get back an error saying this was not a dog. As a developer, I see an error in my code. It's like, okay, my try catch told me something's wrong here, but it didn't give me any details. What exactly is happening? I know that it happened somewhere in my main, and luckily my main's a little short, but I really want to figure out what's going on. So I create a breakpoint. This red dot that you might have clicked accidentally a few times, and I honestly thought I was breaking IntelliJ because I didn't know what debugging was yet when I was using it. This red dot can be a lifesaver. When we click this, we are telling it, because we know that code works sequentially, I want you to stop here on line 16 when you are here. It's basically, think of it as a stop sign. That red stop sign, it's going to stop there. So now what I want to do is debug. Instead of hitting the run button like I have been, I hit this little green buggy looking thing. I come in here and it's going to build just like normal, but then it is going to do a bunch of stuff. What are you doing? Give me a sec. Oh. Let's try that again. There we go. I put the wrong thing. And that's actually a really good tip there. Don't put it on side of a keyword because technically it doesn't stop the keywords. Put it actually on the line of code that you typed. So these blue keywords, not a good place to put your breakpoints. Okay, so as you can see, everything just paused. And it's highlighted with a little check mark there. This is telling me that my debugger has officially stopped at line 17. So if I wanted to start exploring things like, okay, I want to find exactly the line that it's breaking on, I would click step into. And what step into does goes into the method. I want to see if anything inside of this method is actually broken. So then I click over that and I say, okay, everything's fine. My catch statement was not caught, so everything's okay here. I'm going to go back up. Everything's fine and dandy. So I come down here, I keep clicking step over. That's what this one is for, called. Step over just means I want you to step line by line. I don't want you to step into any methods. I don't want you to step into any classes. I'm going to step into this method once again, because I want to just check into the method. I come down here, I press step over. I see my catch just got caught. Okay, interesting. So now I hit my throw new exception line. All right, what's going to happen here? Okay, it comes back up and now it's going into this catch statement. The highlights that you're seeing is literally the compiler, the debugger, going line by line and showing you exactly what's happening. So it looks like now my system out is going to be hit and there's my error. And then it's going to stop and my, and officially then my, I'll go to my terminal here. Yeah, which one is it? There we go. And then I go back to my run and I see that it has that error. But because of the debugger and showing me line by line, I know exactly what try catch actually triggered. It was this one up here. And crazy enough, it's because I passed in a cat. Who would have thought out of all these examples that we've done tonight? So what the debugger does is saves you time and headache to really investigate your code in granularity to figure out where your bug is. That's what the debugger is for, literally to get in there and pry out that bug. And also enhance, like we said, your investigation into what's wrong. If you can find out what line, down to the line that the error is happening at, that is extremely good information to anyone who looks at your code. It's like, I know this error is happening here at line 17, but I have no idea why. Help me, please. I'm going crazy. That is some good material there because you've debugged. You have got your hands dirty with this problem, trying to figure out where exactly the problem is. Again, those knowledge gaps do exist. So we do have to sometimes ask more general questions, but the more detail we have with it, the better it will be for all of us. So I'm gonna open that up now to questions, anything about the debugger or anything that I didn't go over from any of the TAs that would be beneficial to see.
Does the run history help?
Where do you see run history?
I don't know. I found it by mistake while trying to find a bug.
I don't know. Does it help you?
It did. It helped me find out where the error was.
Okay. Okay. Let's see if I can find my views. Is that a run history?
Mm-hmm.
I'm not seeing it. If you can figure, if anyone can tell me, or you can tell me how to get to my, I have never used it, so I have no opinion. But if it helps you, it might help somebody else. So run history.
Could be somewhere on the bottom where we see the output in that terminal. I think I did click on it once by mistake as well. Somewhere.
It looks like it's a happy mistake for most people, though.
Yeah.
Yeah, I am not seeing it. Let's see what I can do here. Okay.
Nevertheless, if I find, I'll just post it on the channel.
Yeah, please do. I'd be happy to take a look at that for sure.
It will give you like each line that you do. It'll just list the line and what time you did it, and then you click on that line and it'll show you what you put on that line at that particular time.
Okay, cool.
As far as the changes, every change that you made in your whole program.
Okay. Yeah, I can't get to a browser right now. So if anybody gets that, please feel free to share it. And I'm going to be looking up, I'll actually add that to my list. And just take a look at it, run history. Cool. All right. Any other questions about that, or any other statements about run history or anything about debugging, investigating our code, and exceptions? That was our main fun stuff today.
Yeah, the text mentions the add watch. Is that a feature you've within debugging? Do you use that feature very much?
You said what was it? Add watch.
Mm-hmm.
Let's see. Not necessarily. I think that I'm trying to think if they mean watch by the breakpoint, but I could be completely mistaken. Any of the TAs have any say on that?
Sorry, tuning in right at the end. It was add watch.
Yeah, add watch. Are you familiar with that one?
In the C# world, when you add watch, you're actually watching a particular variable down at the bottom where you can actually watch it change as you step through your code.
That's right. Okay. That one will absolutely help. Yeah. So if you are ever questioning what your variable would be, yeah, that would definitely help. Let me see if I can get that in debugging mode here. Threads. Sean, do you know exactly where it is in the debugging window?
Not in Java.
Dang. Okay.
Kyle, I think it's that little plus, maybe, like on the side panel between the variables and frames.
Top
Left
where
or
you
right?
have the run button.
Right.
Are we
from
trying
there.
to get into the debug mode?
Down.
Down. Okay.
So like in the debug panel, there's the variables window.
Okay.
And I think it's that plus sign to the left of the args line.
Oh, gotcha. Okay. Does that let you say watch? It does. Thank you very much. Cool. Let's go ahead and actually make a variable, and we'll just go through it real quick because this is actually a really fun thing. String s equals hello. We'll come up here, and then we're going to change it to. Oops. Hi. And then we're going to change it to goodbye. All right, so we're going to stop our debug. It's already stopped. Awesome. Let's rerun that. Cool. So we see hello down here. So this is just, it's actually really nice to see this in the terminal. These are where all of our variables are. Oh, sure. Kim, it is, we're going to press stop here. At the very top here, we placed a breakpoint. Always make sure you place a breakpoint before you try to get into the debugger panel. Otherwise, your code doesn't have anywhere to stop. Press the debug, or it looks like a little green bug at the very top of your toolbar. Click that, and it will build your application and start in debugging mode and get to the debugger panel. There we go, and we're gonna just type in S. So let's go and see. I've actually never used this in IntelliJ. So back in my day, we used a thing called Eclipse. Oh, and it just broke. Not broke, it just stopped. Press the wrong thing. Let's try that again. There we go. We're still watching it, and we're gonna step this time. That would be nice. So now we're seeing our variable in here. We can come in here, and then we can step into the method. There you go. And so basically we can just watch variables using that. I know it can be more powerful. So if you are curious just about a variable in the context of where you're at in the debugger, definitely just set a watch on it so you keep it at the top. It does help. It really does. Like to watch what your variables change to can really debug your problems quite quickly. Kim, did you get it up and running?
Mine just looks different.
Different. Okay. Are you in dark mode?
Yeah.
Okay. Just wondering. Sometimes with all those settings, it can change over a little bit. No, it's not bad at all. I prefer dark mode also. Okay. Anybody else have any other questions about, again, about these exceptions, about the try catches, the debugger, or anything?
I'm sorry, I don't, but I did find it. What I was talking about earlier.
Yeah. Where is it located?
You will go into file in local history.
File, you said, and then
Local history.
am I not seeing it? You might have some powerful stuff turned on. I wish I had that.
It's under. Oh, maybe I do. It's under file, and look right under file properties.
I got file properties. Don't see anything. I do see file properties.
Okay. Well, maybe I have a tab there called local history.
Okay. Local history. So yeah, I'll look into it and we'll see what's going on. Yeah, I'm gonna put something out there. Yeah, thanks for just turning my attention to it. I do want to see what's going on there.
You can try
I
to
see that too. Maybe it's a different version of IntelliJ. Sorry, go ahead. Somebody was speaking.
you can try to alt click or control click in your main window and it might pop up there as well. That's where mine is.
What was the hotkey to do that?
So I'm on Windows, so it's a right click, but whatever the right click for you is, I guess.
I have a right. What did you right click on?
The main window. So just where you're currently highlighted, and then local history.
There we go. Cool. Okay, so are we talking about this, Danny? Does this look like what you're talking about?
I guess the last 12 hours where it says over there in the line by line.
Okay, so this can definitely help with debugging. I do want to make a quick comment about this, that local history just means your Git changes. So the commits that you've done or the changes you've done since your last commit. So this is extremely important though, because if you do have a problem, like what we did in the very beginning of class, we saw that we had a small typo somewhere and you don't know where it's at. Seeing that local history will definitely help. This will not be a part of the debugger panel, but it will help you debug. So great call out on this. If you didn't see what happened there, it's right click and then you do local history. And you type in, or then you press show local history. And as we can see, we've changed up this. And if I wanted to, I can just go ahead and revert. I just revert all my stuff that I just did. Cleaned it all up.
Hey, Kyle.
Yeah.
So I can't seem to get into the frame where you had the plus sign for the watch. I get in the debug on my bottom console, but
okay. During your breakout session, reach out to your TA and see what's going on there.
Sure.
But just to clarify, when you're doing the debugger panel, make sure your variables is shown at the top, and then the plus button should be a new watch.
Yeah. All right, thanks.
Yeah, absolutely. All right, everybody. Anything else that you guys want to talk about? Because we're done. That was it. That was it today. Again, our big announcement is that assignment 3 is on there. Like we kind of talked about, we're preparing to go into liftoff. We are almost there. So remember that assignment 3, assignment 4, as well as 1 and 2 are extremely important to be turned in as soon as possible and as timely as possible, because in liftoff, we're no longer going to be working alone. We'll be working with fellow coders. And we want to make sure we're truly prepared and in that mindset before we do that. Other than that, asking those questions, which you all are great at. I love every question that I've been getting in Slack. And then, of course, enjoy exceptions. And thank you for sticking with me through this one. This one is a little interesting to create examples for. So hopefully most of the knowledge came across. But in the end, thank you all for watching. It is time to go to your breakout rooms. I hope everyone has a great weekend. Stay safe, stay warm, stay healthy. And I will see everybody back here on Monday.
Okay, see you Monday.
Thank you.
Thank you, Kyle.
Good night, everybody.
Bye, everybody.
Bye.
All right. Good night.
Night and night, everyone.
See you all next week.
Okay.
Thanks, Kyle.